All right, I'm calling it shots fired. The US versus China humanoid bot war has officially kicked off on social media. Figure Robotics founder and CEO Brett Adcock has taken on China's UBTECH Robotics, naming and shaming them for releasing a video of their Walker S2 robots that he claims is part CGI. UBTECH, of course, wasn't about to take this lightly, and so they responded tongue-in-cheek with another video saying, quote, "Perfection isn't fabricated, it's delicately engineered." So what's really going on and what are we to make of it? You've come to the right place because my guests today, Scott Walter and Gustav Andersson, are about to give you the lowdown, all the good stuff. Scott is a mechanical and aerospace engineer and two-time founder of robotics companies. Gustav is a hand surgeon and associate professor of anatomy in northern Sweden. Welcome, Paper. Welcome, Scissors. Good to have you back.
Welcome, Rock. Welcome, Scissors.
Paper. Yeah, it's good that we are not the only ones stirring up controversy.
Yeah,
yes.
I'll say, and I kind of looked at it, but I didn't think much about it at first. I didn't do a deep dive into it until people were just texting me like crazy, wanting to know what my thoughts were. And it was one of those, I don't want to wade into these waters because no matter what you say, you're going to get it from one side or the other, if not both.
Yeah.
But at this point, we have almost no choice to kind of look at what's going on. And I put together kind of a timeline of what's going on so everyone can sort of get an idea. So here's the original post that you sort of talked to about there, Royden. And the one thing I think everyone probably thought of, like the one thing I thought of right away was, I've seen that scene before. Okay.
Yeah.
And so this, what we're looking at right here is CGI. It's from the 2005 movie iRobot.
iRobot, yes.
And how the robots are delivered in like the year 2035. So it's probably pretty close to being accurate, this movie. And
do you think they were consciously trying to go for that?
Oh yeah. I mean, come on, look at the gate opening up, their name on there. I mean, the whole thing. So in order to kind of capture that vibe, you've got to do something about the cinematography to match it. So I think they had that a little bit in mind, of a little dystopian, a little bit kind of gray, muted colors, a bunch of the other stuff that's in there. So that may be intentional, and it may, I'm almost thinking it goes possibly a step further than that I'll kind of get into. But the first thing I want everyone to do is, like, this is the original video, and everyone has to sort of judge for themselves. Is there a mix of CGI in there, and where could that be? And would it be enough to be able to tell? So they're pretty much announcing their mass production. And we see this, and this is probably an actual robot. And, that's quite likely that, they have a bunch of those walking around in the office. And you'll see this, and this is a rather large number of bots. That, and then you see something like that, and it's done so perfectly well. And then these scenes here, it's a little hard to tell. You see the shadows seem to be kind of, oh boy, those look like chess pieces there, right? There's a lot of things. The question is the background. Some of the motions there, that's real. Question is, what about that one there? You see the long shadows that are there? There's something kind of going on there. So a lot of people who looked at it at first, they were not really sure what was real and what was CGI. And I know a little bit about computer graphics because I've delved in that field long enough to kind of know what's going on and what to look for. Again, you're not seeing much of a shadow here, but when you start looking there at what the feet are actually doing, the physics of what's going on in those feet is actually correct. You see everything in there. It seems to look all right. So what's CGI? What's not CGI? And then I talked to John Gibbs, and he actually teaches that computer graphics and animation for a living. So he really knows it. And he was also kind of confused as well. He says it's really a hard one to call. And
really?
Okay. Yes, it's so very hard to call.
At least their CGI is on point. It's pretty
well, or it may be something else. So of course, what ended up happening here is that there were a few things that potentially could be off, and it's always difficult to look at that because reflections are really difficult to do. A lot of times when reflections are done in CGI, it's kind of like copy paste here and there. So there can always be a lot of bit of suspicion, but it's very hard to track it down. Now I have looked at the number of light sources that are up above, and like there's 8 rows that go across, and you can actually kind of count when you look at them in the different sides that the numbers match Here it's a bit trickier. You could almost, John Gibbs thought he only saw 6 in there. I believe I saw 8 actually reflections going along there. But there's just some inconsistencies, and a lot of this could come from the way it was shot and potential post-production that was done to maybe clean up the fact that there was like a cameraman standing right in front of it and you're seeing the cameraman in the reflection. I mean, a lot of things like that could be going on. So based on this, this is kind of a close-up on here where you can kind of see it. I think I can count the right number that's there. So I think it does match up with everything else, but you could be easily forgiven to be tricked by what's going on, because it certainly looks like it could have been produced that way, because CGI is so good.
So if you just go back to the previous slide.
Yes.
So what stood out for me was the second robot at the back, that circle at the back. Yeah. So the depth of field is inconsistent.
Yeah, well, what's going to happen is that you do have a very tight focus, and the further back you go, the more blurry it's going to get. And the result is that you get that kind of that bloom. But the thing is, it almost seems inconsistent between what's here. Is that from here to there, it seems like almost too much.
Yeah,
and that's why.
Also, if you look at the top, of the head of the second robot is a lot sharper in focus than the rest of it, than the rest of the head.
Yes. And so that's why.
That's not how depth of field works between the first and second one.
Yeah.
Either you'll have it all out of in soft focus, or you'll have every part of the second head that's visible in sharp focus. We won't have the same object in two different.
Right. Now, the thing is, there could have been a certain amount of post-processing going on here. So when I looked at it, I was wondering, all right, I think there's some reality in here, and a couple of shots that are set up that just strikingly almost look so artificial. You think, oh, well, maybe that was a storyboarding that they were setting up or doing something like that. Now, I'm just going to ask you a simple question: do you remember who kind of won the engagement wars last week? The humanoid bot company, who that was?
I think it was Xiaopeng, quite definitely.
Xiaopeng, exactly, and they won it because of a controversy, right?
Yeah.
And what was the controversy?
Yeah, controversy that it was just too real, and everybody thought that it was a person and not the bot when it did the cat.
Now, who started the rumor? Who put the seed in everyone's head that it could be a person in a suit?
That I don't know. Do tell.
The CEO in his keynote address.
Yeah.
He basically started the rumor. He denied it, but he kind of said, "Oh, there's a rumor, or people think it's so convincing." Of course, Elon has made a similar statement about what V3 is going to look like. So he's like, "Hey, this is a great idea," and so in many ways, it's almost like, "Hey, this is how you get the engagement." So everyone did was they talked about Xiaopeng last week, and we did a video about it. Everyone did a video about it. Okay, now it's rather interesting that in less than 48 hours after that, UBTECH already has their reaction post in video ready to go. It's like that thing was in the can, ready. They knew exactly what they were doing. Okay, so if you want,
but
go ahead.
I thought this. Can you go back to the previous slide, because I thought that post from UBTECH was in response to Brett.
Yeah, but they had prepared it.
It was indirectly. It was indirectly. Right. In some ways, they said what was too perfect to be real. They don't directly go to the controversy. They don't mention whether they thought it was CGI. In many ways, even if this part wasn't ready, they already had the video set and ready to go to say, okay, we know people are going to think this is CGI, because I think they wanted it to actually look like CGI. That's sort of my reading on that. And so now when you look at this, you can see this is the raw video of what they did. And you come on down here, and they're using a drone that's going very fast. So this is a slow motion of the drone shot, which means the resolution is kind of poor, and you get a lot of blurriness in the ceiling. So the ceiling almost looks like a texture map ceiling. It almost looks artificial because of that, depending upon the focus that you had. The lighting has been set up here that it's very hard to tell that the shadows, but that could be done through exposures and a lot of other different settings. We're going to turn around here, and then all of a sudden we're going to see a person down there. That was probably the drone operator. We see the lights are blinking out of phase and everything, which means they're not like synchronized that you would typically see maybe in some kind of, if it was computer graphic generated in many cases. So they're blinking around, and now you see the camera crew way over there. So you begin to see that, oh, there actually were people in there. Yeah, they could have faked that if they wanted to, I suppose, to make us think it was real. This is the image that kind of caught Brett's attention there. But the interesting thing here is that we only have 25 bots walking.
Exactly.
And you get the impression that all of them, and I think there is about 200 bots. So based on what I've seen there, it looks like there might be about 200 bots in the entire scene. Only 25 that I'm going. And there have been a lot of other things that are going on that we kind of go back to some of the others that are there. So that was the original one coming in there.
Why,
and I might go
why
back.
just have 25 moving?
There could be a bunch of reasons. One, depending upon how they had to do the coordination with Wi-Fi, is it may have been like too much on that. So
I see. Okay.
I'm not sure that that's necessarily the legitimate reason. It might be you've got 200 bots that you're trying to put in perfect position. So when you look at how everything is lined up, and sometimes, especially when we look at the diagonals, everything is just perfect. It's like, man, they're really lining them up. So you're talking about herding cats in a way, and you got to make sure they have to be able to stand rigidly for the hours it's going to take you to get everything done right. You've got to try to set that thing up. And so there's a good chance that a lot of the bots that were there were deactivated, that they may have put something in there to actually hold them in position. They may have put some locks in some of the joints so it could literally be what I'd call a terracotta bota just standing there rigidly. Now, that scene there, this is, I'm going to come back to that. Sorry about that. Is that if we look at the delivery of what's going on here, there's a few things. The clips happen so quickly, you lose your reference. So I had some points of reference going on in here where I got a little bit confused and trying to do like my overall counting. So right here in this scene, PowerPoint is the worst with being able to stop a scene. Let's see. Here we go. Let's see if we can get back to where it is. Let me see. I want to drag it on, and I think we had it back a little bit further. Okay, right there. If I can get that to stop. All right. So here it's you get the impression you were like front and center. Now you're not front and center. You're actually at the far corner. Yeah. So you can count that there is basically 4, 5, 5. So the phalanx way over in the far side is only 4, and it looks like it goes back about 14. And then you have 5 in the middle that go back 14, and also here. And I'm not sure that there's roughly 14. And I saw a couple bots that looked deactivated that were off on the side somewhere else. You do the math, you get like 196 or something like that. So let's call it about 200. These bots here, you can see, are already missing their hands. Or let's say they have the hands that are meant for the battery swap, whereas the ones in the middle still have it. So what ends up happening is that we get disoriented and we think the bots that we were just looking at change their hands instantly. And that's actually not the case. Is what they do is that when they did the battery swap, they were looking somewhere else for it. So 25 came in with those hands, 25 came in to basically do the walking, and that's it. That's kind of the organization. So now if we quickly go back, let's say to the first video that's here, when we look at that, and I'm going to try to find where we see the battery swap. So this here, they shot that in such a way that they literally look like little figurines on a table. Because they get the perspective, and you can do that. I mean, you can make figurines actually look real, and you can make reality look like figurines if you want. That's just what camera operators, what good directors are able to do. So you get past this, and we get so this swapping here. So what that means is that suddenly now they've moved the drones over to
the right side,
the right front, not in the middle, and those are those bots. And they took those bright lights that we saw down at the end, because they were using those lights to basically crank up the ambient lighting in that hall so that your shadows got muted and basically disappeared. So you would think, oh, this is CGI because where's my shadows? They're gone. Those have been brought over to the side now. They're down very low, and they're casting these very, very harsh shadows that most people would say that is a sign of CGI. I mean, it's like that to me, it's like I would look at that and say, oh, that's very clear. Whenever someone makes the sun kind of setting in their CAD system or something like that, it's because they're trying to get a certain contrast and it looks fake. But it's not, it's just, it's done in such a way that you would be, and especially when you contrast that, when you come on in here, and I think, right just before that, you see this. So suddenly they go to high fidelity where you say that's reality. But when they go back to the other, the quality is so bad, you're like convinced. Okay. So this whole thing was designed as a psyop to try to make everyone think it was CGI, to get in a big argument about whether it was CGI. And now you and I are all talking about this, as well as everyone else, as well as the engagement that's out there. This is all everyone's talking about. So they won the week.
But also, robotics. I think in the next couple of frames at 26 or so, I think the hands switch.
Well, see, that's the whole thing. Is it looks like the hands are switching. So what you have is you have these hands here. If you, as you kind of go along, and that's just the fact that they did a cut, because what they're doing is they're showing you a different phalanx here. So that's and those are the ones that are all the way to the right next to the wall. But you're kind of disoriented. You think it's the original ones you were looking at, and then suddenly it will jump back. Oh, see, look, the hands came back on. That's because they're just shooting a different row. And again, the lighting and everything is kind of done. Then you're starting to see the shadows being cast a different way. So there is a lot of little stuff going on there. Now, when you start to look at the walking, especially when they're coming out, you can see when you look at the feet that they look actually quite convincing and quite real. I think there were some close-ups here where you can see. Now, the synchronization
this is the part that looks most fake to my eye. I mean, most like Star Wars.
It's so perfect.
Where it looks so perfect. And in the next few slides, when you see them directly in front, they move perfectly in sync.
Every single step there. Yes, every step looks perfect. You're seeing the soft shadow underneath there. You're not seeing the diagonal shadows. Where is that coming from?
How do you think they got all of these bots to work to walk?
They only got 25 to walk. Well, you just put the same routine in there. Okay. Have you ever been to a Tesla light show?
No.
You're able to synchronize like hundreds of Tesla at the same time. Is that you just have a countdown timer, and those start it right now, and all the lights are synchronized. So it's sort of the same thing. And how long they can stay synchronized, I don't know. It might be that after 30, 40 seconds, they start to lose a little bit of it. But what was going on there was almost perfect. Yeah.
Okay.
And you can see when the feet come down that the contact and everything looks realistic.
Yeah, doesn't sink through the floor or anything.
It doesn't sink. And not only that, you see the feet kind of bounce a little bit when they go down.
Are those cameras there in the feet?
I think it's just,
no. That's
just the pin.
That's just the joint. That's just the cardan joint that's there. The axle that's there for the ankle roll. So you'll see it kind of pounds. It goes on there, but there's enough about the shading and also everything else in the environment that's been done in such a way. And again, it might be they just wanted to get that iRobot vibe. And because of that, they ended up capturing a CGI kind of vibe that gets in. And again, it could just be intentional, because how else, if you want to get people talking about it, go ahead.
So this is all real, is what you're saying?
I believe it's all real. Even the shots that look fake, I think they're actually real because they tried to fake them. Now, this is the hall that they were in.
Right.
And again, I mean, this could have been like a green screen behind the people. You can always cut and paste. We have no idea where this is actually real. I will take them
that would be
by their word. They thought everything out. You see all these things, if you want to call them either porta potties or caskets, I'm not sure which.
In the back,
This is actually how the bots came. So there's about 32 over here. There's probably about 8 rows going back, or 5 or 6 or 7, whatever. It's how the bots are transported. The bots do not walk into the back of a trailer, turn around, and get shipped that way. No, they're getting it shipped in that. That was just theatrics to be able to show that. Okay, the idea of themselves walking in there. So now, if we kind of compare the two, of course, the lenses are different. This is probably more of a fisheye lens versus a deep kind of focal. So the perspective looks a little bit off as far as it looks a lot taller here. It looks a lot narrower there. I think it's just the way it's shot. The main thing is that you'll notice they did something to sort of change the color of the hall. And that, again, could be done through effects of the lens.
It could also just be different because, so they both clearly are possibly drone shots using the same drone.
Yes. And one of them just
Just
playing
the white
with the
balance
color
would be
maps a
off.
little bit. Yeah, the white balance. Now remember is that they had some pretty big bright lights in there, so they were intentionally flooding it with a certain kind of light. And there may have been some preparations on the floor also to just make the effect there, because you were looking at that almost expecting the feet to go through the floor. So it almost looks like a CGI floor versus a real one. So to me, either that was like a real hall that they went in and then scanned it and created a point cloud. And we've got, Gaussian splats up there. That's the environment that they're running the CGI in to trick us. Or it's just that they shot it in such a stylized way that it gave that impression.
Yeah.
And I'm leaning more towards they have it, because they already mentioned a few months ago of an order that was like worth close to, I think, over $4 million that needed to be delivered at the end of the year. They didn't really give the size of the number of bots. It's about 200. This bot, I did a review on it, and we kind of look at it. Okay, so basically, some of those off of the side, I think, are the terracotta bota because they may not be moving. I think they're just deactivated. I don't think they're like mannequins, but you never know. It could be that if you want to say it's not CGI, you could do something like that. So I just, threw a bone to the conspiracy theorists. And then you can also see here, again, if this is part of the PSYOP that everyone wants to run, you can see over here the stands that are being rolled in on, the supports. So either that was like someone didn't catch that in the editing over here, and then kind of turning them on to make sure. And again, it's shot in such a way that's like, boy, it does look like CGI. So my review was, and it's a long thread, is that the bot is kind of very mid. Absolutely nothing about it screams best in class, but strangely adequate from head to toe, already deployable and scalable. I shouldn't really be that impressed with the bot, but I actually am, because when I went through it, it's like, they may be like average everywhere, but when you sum them all up, they're actually more performative than those that are world class in some things. So Unitree is world class in running and doing backflips, but it doesn't have hands. It's too small. We don't know about the durability of this. So
so it's the best generalist out there. Which
basically, they got to market really fast by focusing on what is a true MVP kind of product. 11 DOF hands. A funny kind of wrist. It's their second generation. Their first one I was not impressed with at all. But the second one, they actually made a lot of improvements, and they added some functionality for a very kind of narrow application, which they want to go into warehouses and everything else. So it's quite feasible that they really are shipping to a customer that really wants a large number of them, and that they're actually able to build them, because there probably are no components in there that are wildly difficult to produce. They, with the supply chain that you have in China right now, it's all well within the realm of feasibility, because these aren't tendon-driven hands or anything like that. They seem to be all mechanical linkages. I believe that they could actually produce this.
And this whole CGI drama thing, I mean, I was a few, like 6 months back or something, when some of the Unitree videos came out. They looked really fake to me, part of them. And then you saw a clip of it doing a similar move set of Kung Fu or whatever, where it was a little bit more stumbling. So I was like, no, that original really had to be CGI. But now they've shown that the bot can actually do these things. The videos they send out now of the Kung Fu flips and the opera theater or whatever, it really is the bot. So in the end, even if the first one in the back, it's like in a back alley doing some Kung Fu moves that I always felt, this looked exactly like Unreal Engine or something. Even if that was fake, I mean, in the end, they managed to get it to that level. So does it really matter? I mean, it's a bit, if it's fake in the beginning and you don't say it is, it's a bit unethical perhaps. But I mean, they deliver. And then, as you say, perhaps it's just going to last for a few hours doing those Kung Fu moves. I wouldn't know. But here's the same. If half of those bots in the background were CGI, I wouldn't really care if the front row was actually the real deal moving into whatever positioning. It's just, we got 100. We want it to look like I Am Robot, so let's copy paste.
Now, to show you the difficulty in scaling, about this time last year, we were hearing rumors out of China about a supply chain scale up for Optimus, where the suppliers over there were being told to prepare for 30,000 run rate by the end of 2025. That what they should be able to produce enough components for 30,000. And then, sort of in January, February, we were also being told that the internal targets for Tesla were about 5,000, with potentially a stretch goal of 10,000. So I want you to think about that for a second. We saw about 200 bots in that warehouse. And we're talking about, a lot, you already need 5 times just to get to 1,000. So 5 of those, and then to get to 5,000. So you're talking about an order of magnitude and more to be hitting numbers like that. And so we already saw what the production line looks like. Now 10,000 bots sounds like a lot, but if you're able to produce 40 a day, one shift, 5 days a week, you can still hit that. So it's possible to hit that. You just have to make sure there's a supply chain for a lot of the components that come in there. And we can see Tesla already had that, and then they stopped. And part of the reason they stopped is they realized that the bot did not have the reliability that made it scalable yet, partly in the hands and some other places. So already it's like, wow, it's like it is. Tesla was already thinking of 5,000. 200, while impressive, is not super impressive. It's still not 1,000. Unitree may have produced more already. It's just that this might be the largest mass shipment because everyone's buying onesies and twosies. And now they're saying, woo, let's go ahead and deploy a lot of it. Now, the reason that Tesla has ostensibly decided not to move ahead is probably because the hand didn't have the reliability that they wanted. And I woke up this morning, and unfortunately, this person tagged me in this post that Elon replied to. And therefore, as a result, I've been seeing all the replies. It's like my notifications are just kind of going crazy here. And in this interview, and I think there's confusion in the interview. You can watch it a bunch of times. I think Elon just got a little bit confused himself. There's not 100. I do not believe he's saying there's 100 actuators in the entire bot.
No.
And he corrected himself. He said that he meant that the 50 actuators was between both hands, not individually, and there's only 25 in one. So that's an interesting data point. Because remember, we did a breakdown last week where we tried to count the number of actuators in the forearm based on previous statements and everything else. And so from that, I'm assuming that they've increased it from 17 actuators now to 22 or 23 for the digits, depending upon how you count the wrist. And so that means they're adding at least 5 more. And where do you think they might be adding those 5 more, Gustav?
Yeah, so I mean, we've talked a little bit about the ab and adduction that we try to kind of how many actuators are there? Is it just 1 or is it 2 to produce that? And I mean, the 3 up here, we've seen the 2 pistons for the flexion extension and radial ulnar deviation, which would also be able to do the circumduction. And then the third, I guess, would be the pronation, supination. You could do that with 1. I guess.
Right. And I don't think that's counted technically as part of the forearm because it's like outside of the forearm. The forearm is attached to that. So that's why I say only go with 2. 25 minus 2 is going to be 23 in there. So they may be adding 6 actuators over the 17 that were there.
But we can throw up the anatomy slides just to kind of prepare this for last year. So this is basically all the muscles that we have in the forearm on the left and the hand on the right. So there are about... You can count them as 19 muscles, but some of them, like the extensor digitorum number 12 on the left, it has like 4 tendons, even if it's counted as 1 muscle. But so that's basically the setup we have, and this is a lot more than whatever 22 or 21 or 24. So if you go to the next slide, that's like what we kind of thought if we took away the unnecessary ones. And now I actually kept the pronator, which is one of the rotating one, but you can remove that. But if you count them up now, it's around 14 on the left and 12 on the right when you count each individual extensor for each finger, and you need one for the thumb. So basically you have 2 muscles in this list that would do the extension, flexion, and radial and ulnar deviation, similar to the bot design. And then you would have 5 flexors, 1 for the thumb, and then 4 together for the finger, which is called a deep flexor, the profundus it's for. So 5 flexors, and then you need the extensors. So you have 5 extensors for the fingers, and then you would need the muscles that kind of abduct the thumb, because there is no interossei for the thumb. It's its own muscle that abducts it. But if you count the ones that move the fingers away from each other, that would be 5. and then those to move them together, you would have another 5, unless you could do a similar setup as here, that you use only one actuator for both these motions, one to kind of move it aside and then just reverse it to make it come back. I'm not sure if that's what they're doing. In our case, we have one muscle that splays, so or one per finger, so 5, and then we have another 5 to do that motion. And then you need, and which Tesla have shown both for the 5th and here, that you need something that kind of prepares for the opposition, both of the little finger. They have this joint for the 5th metacarpal, so that's another 2, and then probably that's enough. You could then probably use the flexion. I'm not sure they need to. In our hands, we have 4 muscles here and 3 there. Basically, one that does the ab. This is actually the abduction of the thumb, moving it into out of the plane. And then we have the opponent's muscle. That's if I can show the opponent's muscle that actually kind of moves it over together with the flexor to do the opposition of the thumb. So, but I'm guessing that they could probably kind of do that with just a motor or abduct, something that puts it out of the plane, and then you just use your flexor and adductor to kind of move the thumb into position. I don't think they need 2 more muscles than they already have with the flexor and the adductor. Just take that one together with this one, and then this one that moves it out. Those 3 together could probably emulate opposition. And the same for the little finger. We have 3 here. One that is like a short flexor, something that moves the 5th metacarpal into position, and then something that opposes it. So we'd have the abductor is part of that. So we have the abductor and the flexor, and then the opponents that moves it over. And they could probably do that with just one actuator to move it into place. So once more, 3 up here, and then for displaying, you have 5 that way, 10, 15, 20, or that would be the extent, and then another 2, 22. So that's where I would go.
And that, ladies and gentlemen, is a masterclass from Dr. Gustav Andersson, which you will get only here on Over the Horizon.
I was trying to remove my anatomical knowledge to see how would an engineer think. But
okay, I'll tell you how an engineer thinks. So we looked at it last time, and it's supposed to be a 22 Doff hand, and we've tried to figure out all the tendons that you need in there. So do not mix up degrees of freedom. So it's actually 22 jointed. So there's like 22 different kind of motions that you can get in there, and the question is what the actuation strategy is going to be. So we've looked at it, and we can see that there's a flexor that goes through there, and there's 2 abductors that allows them to go ab and add back and forth, and then they have a flexion tendon, and then they don't have a tendon for returning. Effectively, they have a ligament, which is like an extensor ligament, if you want to think of it, basically a rubber band that looks like a tendon that when you relax the flexure goes back. So if you kind of look at the number that they're going from 17 actuators, maybe to 22 or 23, depending on how we do that count. Well, 22 minus 17 is conveniently the number 5. And that's exactly the number of rubber bands that they've got in there. So what it might be is that they've decided for control and stability, they want to put the flexors in there that will give them a lot higher degree of control. They're probably still using what a torsion spring returns down here for the opposition on both of them. So that's my guess, is that they'll still allow some kind of spring return. But the advantages of the antagonism that you now get from a real flexure is they may be able to reroute the flexure a little bit, and also get around this problem that I've noticed, that if you take the tip of your finger right now, based on the way they've actually got it set up. So I'm going to be looking at it something like that. So if I push on that right there, a force in there, I get abduction. And what I want to do is I want to push back and keep it in the neutral position. And you see, I can do that, and I can get back to the neutral position without flexion. But the way they have it set up is like in the front, they actually have the abductors kind of here in the corner. And so the abductors can do not only add an abduction, they can also do flexion down here at the MCP joint. So if I try to resist here by just going with that single abductor, as I do it, I'm going to induce flexion. So the harder I push and the harder I resist, the more it kind of goes down. That will be kind of funny. So the only way you could resist that is you would need the extensor fighting back on you, because right now they're dependent fully on the whatever is the built-in tension on that basically rubber band that's helping to pull it back. And so this way they would be able to get a little bit more control and maybe stability, because because we kind of notice the fingers are like always like they're never like that. It's always they're around doing weird things because they can't keep it locked in. So I think for both stability and control, if they want to lock that down, that's probably the main motivation.
I mean, if you add the extensor for the thumb as well, instead of just having the rubber band or the string to stay it would help you with repositioning the thumb as well, even if they have a small spring still here for that getting it back. If you have your extensor, it would reposition the thumb with the extensor as well. And that's how we do it. We have the long extensor coming here in the back.
And they could even do a trick to say, well, we'll leave the rubber bands in there, but we'll also add an extensor. That way maybe they get a little bit of support, just like you'd have like a counterbalance in an elevator, so you're not having to fight all the gravity. You might already have something like that kind of works, and then you can use this for the additional antagonism to get that kind of control. They might also change the CMC a little bit now that they have that, because it's been confusing to figure out what the degrees of freedom are down here at the CMC joint. And I looked at a slide and I asked, it's like, how many degrees of freedom are at the CMC joint? And the answer you get is like, well, there's really 2, but as things, it almost looks like 3, because as it goes around, you get these other kind of movements that sort of happen. And when we looked at Tesla, at the Tesla thumb, we couldn't really figure out where the abduction was, because they have flexion. It's pretty clear where the flexion is. And then they use those 2 abductors to do the flexion at the base. So you think of the flexion being right along there. And then I'm trying to say, where's the thing that actually pulls it up like that? There isn't really proper abduction on there. What they're doing is they're giving extra control on the first metacarpal.
And I think they need that. I mean, they didn't show that with this Gen 2 hand. It's actually moving into the side. And they need that one. And also, it's not, you shouldn't forget maybe you our patients miss when you cut their long extensor tendon. It's first of all, you can't really extend the distal part of your thumb. Some can, because another muscle can kind of help with that, but they lose the ability to kind of move the thumb out of the way. So it's going to be in this position and get stuck. You need quite often to actually move the thumb backwards, not just to the same plane, but actually further back. It helps you in gripping things and opening up your palm. So it might be that they both those things are not enough to just have a spring set up. You need something to kind of actuate it a bit further out from the palm, and as you say, to kind of get it in there as well. I would like for them to have that as well. But then how they design so there's like multiple joints here. You have the first between your scaphoid and the trapezium, which is the ST joint, you could call it. And that is actually gliding a little bit forward, the thumb forward towards the palm. And then in the next, you have this famous CMC or saddle joint, or the TM joint, or whatever you call it. And that is, since it's saddle shaped, as you say, it's not just this way and that way. That would be 2 degrees of freedom, but it can kind of rotate a little bit there as well. That's where some people say, oh, it's like 3 degrees or 2. So it's not just 2 hinges. It actually kind of can be And the same with the MP joint. This is also like it's both. We see it primarily as flexion extension, but there is some ab and adduction and also slight rotation. So since the shape of that joint is not perfectly circular or flat, when you bend the thumb, it will kind of rotate into
forces it. It's like a mechanical cam that gives you some additional motion. And that's why in the labeling of my diagram of what everything was, I labeled a joint opposition. And I'm not sure if there's technically like an opposition joint or an opposition direction. It's from what my reading of what it was sort of showing the literature is like a combination of flexion and abduction and rotation gives you opposition. Exactly. And so, but they couldn't figure out how to get that kind of combination in there. So they kind of built a hinge in there that has the effect of opposition. And then unfortunately, we're sitting here trying to name that thing, realizing it doesn't match the human anatomy quite right, but it gives you the purpose. And that's why I was trying to tease out that you need that rotation, because they say, well, there's 2 degrees of freedom there, but as you do the opposition, there's actually 3 rotations going on because of the fact that you get an imperfect joint there. That allows the opposition. And so it means they actually have to get it to bend a little bit. And so I think your thumb is rotating like plus or minus 10 degrees. They have just enough antagonism between the two that if they just pull on one side, that joint will go just a little bit, but that's it. It's not really meant to twist.
And it's the same for these joints as well. I mean, when you close your hand, they will rotate slightly in towards each other. It's not just that the metacarpals are moving and that they're bending or directed in a certain way. They are actually rotating a little bit in the flexion. So this joint you can of course abduct and adduct and flex and extend, but there is some slight rotation in that joint as well as we're grasping things. And also for the PIP joint, it's mostly hinged, but it will be a slight rotation there as well to kind of reach in towards the middle. Whereas this one is primarily just hinged.
Unless you have like a perfect pin joint or something like that would resist it, because when you start tugging on those things, it's not like the forces are always aligned exactly in the direction you want to go. There's a lot of side-to-side motion that goes in there, and because of the compliance of the joint, as you do that, it's just going to say, you know what, I'm just going to go with the flow here and kind of minimize the overall tension. That's why, like you say, you see those things even though they're not obvious, and we try to design them out, but actually we need to consider designing them in.
Exactly. And when also what we have that these bots will have to kind of, I guess it would be good if they can emulate is our ligaments, the rubber bands or the stiff bands that exert too much motion. So in this position, the MP joint of the fingers is very unstable, but when we flex the MP joint, they become very stable because the ligament is positioned in a way that it gets shorter here, and when you flex, the ligament is tensed up. So here they are very stiff. Now I can't ab and adduct my finger anymore. Whereas when I'm here, it's easy for me to just pull it aside. I don't think that it's very easy to kind of design. And maybe when you have a real hinge, you don't need to add that stability. It will be flexible enough. But there might be problems with some motions. Or
the problem is it's too flexible. The problem is that they have a hinge that allows you to do that.
Yeah,
which means when you're down here, that hinge still works, and you want to get rid of it. So it would almost be nice if they had, like you say, some kind of stabilization that just happens automatically as you go around. The tension comes in there, and now you prevent it from being able to do it. Or there's some other way of designing that mechanism that as you go down, literally the limits just harden. So I think there is some way that you could design it that your abduction basically gets restricted as you go down. And that would be much smarter than trying to control it with tendons, because then it gets more wobbly. You get something down there that's it's like a physical impediment to you being able to move, as opposed to a control system that's trying to tease out, well, what tension do I need at this instant to get it in location?
Okay, in terms of functionality, adding these 5 actuators, what does it do to quality of motion, grip, movement, and how does that translate into actually being able to do maybe tasks that without these 5 extra actuators you couldn't do as reliably?
I think Scott was onto it a little bit with how easily it is to control, but perhaps also you don't kind of, the rubber band design it will break after a while. At least that's the way I consider it. Like if you pull on a rubber band too many times, it will break after a while. It'll be extended too much. Now you have direct control of that motion, and also perhaps they realize that there are certain things our hand can't do. We can't really make this key card grip with the thumb. It would just turn into a flexion because we didn't really have a thumb adductor that does that motion. Perhaps, I'm not sure. And also the moving the thumb out of the way or whatever. So I think there are both, you could control it a lot more, but also add stability. And when we consider a good human hand, what comes first on the list as hand surgeons is sensation. If you don't have sensation of your fingers or some kind of feedback, it's a bad hand for us as humans. And the next part is stability. If you lack stability, it doesn't matter how much you can move it. If you can't grip something with stability, it's a bad design or bad hand. And then you come to the next, okay, first of all, we want to be able to pinch something. If that's all we have, it's better than not having it. And then we go for the tripod grip to have more things. And then you add more than 3 fingers to have, and of course the opposable thumb is part of the tripod grip. That is really important, to have a thumb in opposition. It can be fixed in this position and still be a quite good tripod grip, but then you would of course lose other types of grips perhaps. But a stability comes before mobility when we're talking function. So sensibility or sensation, stability, then you get the opposable thumb, and then you start adding degrees of freedom, if you like, or number of joints.
Yeah.
And then you can, for us, we stop at the 5-finger hand, but in theory, 6 fingers perhaps would be better. Probably not for what we're doing.
So if Optimus is going to be the ultimate surgeon, are the 5 extra actuators going to help it become that?
You know,
I mean, does it need the 6th finger?
I don't think you do. There are surgeons with 3 fingers who are really good, and they need sensation. They need to feel. I mean, you could see a lot of things and understand what type of tissue it is. But what I find myself, the thing that I think I developed the most over there is just feeling what type of tissue I'm cutting in with and this might not be the same for all types of surgical fields, but when I cut into the finger or whatever, I feel, okay, now I'm cutting through palmar ligament, and now I'm coming down to, it's not the same, this is something else.
And that's because of the resistance that you're feeling.
Exactly. And there was this study about us humans being able to, if we push our hands over sand, we can detect solid objects in the sand, even if we don't feel it. But how the sand is moving and the vibrations, our hand can detect that, okay, under the surface here, there must be a rock or something. So we have that really fine sensation of, okay, this is the resistance here tells me it's a scar and not the nerve or whatever.
But will that come from these actuators, or will they come from like palm sensors and fingertip sensors and things?
Probably both.
Both, yeah. I would say both, yeah. So
and probably something in the joint as well. Perhaps you could add like a. So that I mean, you could have a 3-fingered surgeon who's really good.
Yeah.
If they have
color me impressed. What about you, Scott?
Oh yeah, and I think we saw from those blinking LEDs, they probably have encoders at all the joints. So not only are they measuring the tension that's on the tendon, but they probably are getting some other information about that, as well as what looks to be pressure sensors. And assuming they can detect not just touch and pressure, but also shear, which is very important to knowing that you're not dropping something. Now, go back to put my post back up again, or my PowerPoint up again, because there's something else that's been nagging me in my background process right here, and that is what Elon. He was a little bit confused when he was talking about and he cleaned up his language here. So it was very hard to figure out what he was referring to. But now I think we can take this as a very precise statement.
Yeah, and I know what you're thinking.
Forearm and hand. Okay?
Hand, yeah.
He didn't say that they're all exclusively in the forearm.
Exactly.
So it might be that they're actually going to a hybrid model.
Yeah, he said exactly, or more or less the same in the video. He said there are 50 actuators in both forearm and for each hand and forearm. Oh, and that's 100. And then he kind of corrected himself.
When he said, "Oh, that's 100," that's when I was like, okay, so he's probably not got it wrong because he's
So they're not going full Wuji hand here, where they're putting like all the actuators in there. Because he's clearly saying that they're in the forearm, unless he's being sly and just saying, well, that includes like just the wrist actuators. But I think he means that like there's probably some down
I was going to ask you that, because how much of the wrist factors in as the forearm, or does it factor in?
Well, my feeling is that the wrist and hand need to be co-designed together. You can't have the idea, I'm going to build a bot that doesn't have a hand, but I'll supply you the wrist, and vice versa. I almost think a good hand design needs to supply the wrist in that it gets attached up here on there. Just because if you're obviously if you're going to be tendon driven and you're going to put it in the forearm, well, where are you going to mount it? You're going to have to mount it there. You can't mount it up there. And your wrist has to be set up to have a carpal tunnel. So you have to really be cognizant of how you create that and what kind of wrist actuation mechanism you want to have in there. And the other thing is, I think the overall control system for the forearm should be integrated, that your wrist movement and your finger movements should really be tied together, not considered separate. So I do like the idea of thinking of the whole mechanism is coming from there. So it could be that, let's think about it. What would you put and where would you put them in the hand if you wanted to do that? Is it because you've got some powerful actuators that you think you can fit in there, and now the run on those tendons you want to have are a little bit shorter. It's a little bit easier to do it, but then you wouldn't really be able to have a flexible palm. The other possibility is it something almost directly at the ab and adductors. So if you had a motor, especially one that was of good strength right there, you don't need to now have two to go ab and ad. You can have one there, which then means you should reduce the count, but maybe it's
you have 17 again.
but since we have all these others here, maybe we can put them to other use, so we can have like a double, or we can have two flexures or something like that, or just some other things. But the main thing is, what that means is that you could probably get stability in your ab and adduction, like they've been losing. You get precision and you can hold it.
Yeah, that's always been my concern when they move everything up here. I mean, it's really hard to. I'm sure they could figure it out with their AI and their magic, but I mean, tensing up your fingers in this position and doing it in this position is a lot different. The torque or the force needed here is a lot less than here. I have to exert more force to close my fist here than here, because the tendons are becoming slack, and as I go here they kind of flex by themselves because the tendons are still stuck there, and now that I'm going over, it will flex up. So, and we saw that in the air guitar, like when you could see when it's keeping this finger, and when it does this, the fingers kind of flex and extend as it's moving the wrist. We can control it, but as those tendons are running over here, and then when they do that sign, they kind of flicked over, or if they're overextended, I don't remember. But you could really tell that they can't keep the fingers straight as they're moving the wrist. So if you move a few muscles here, it's a lot easier, I'd say, to control this. Then like, okay, I want to spread my fingers now, but then if I flex, maybe they would go together, or the other way around.
Okay, well, I've been wanting to ask,
but I got another idea on that. Just kind of think of a second, right? Is that maybe we're wrong about thinking of going after the abductors, because we've been talking about that they need to actuate the extensors, and maybe that's where they're putting. So it maybe that fits in there. That way you don't have to think about, oh, we need a bigger bundle. I mean, if we put them all down here, now our carpal tunnel gets even more difficult with more of them in there. And it might be they're saying, hey, it makes sense, just go ahead and fit them in there, and we'll get that intrinsic control that you would like to get. So maybe that was how they get the fine motor skill. So if they're going hybrid, maybe it's the extensors they're going for, and not the ab and abductors.
When you look at the human hand, our fingers actually extend into kind of halfway through to our palms. And then, but when you look at the fingers on a bot, they're not the same. So you have that much of a difference when you have to account for between when you're trying to transfer human biomechanics into and movement into the bot. How much of a kind of challenge is that? And what has the greater advantage, the human hand or the bot?
I mean, what they also lost, we talked about before, was the Fibonacci sequence of actually clenching the fingers tight. If you move that joint up, you would lose that, I think. It would at least be hard to get it in there. And this also comes from the joint in the humans not being a true hinge. It kind of glides down under, and then it glides up. It's similar to the MP joint here, here it's very mobile, but here it's stretched. And that's because the joint is like moving down a little bit, and I don't think that will work the same with a true hinge. Perhaps it will, but at least it will be hard for them to really get this sequence. If the maybe you can kind of compensate for it if you make the phalanx shorter, perhaps that will work, but I'm not sure. So I think that is one part of it.
Yeah, and you're right, Royden, is that it's not so much that our palm moves, it's that our fingers actually end down here and not up there like we think. It doesn't end where the skin is. And mechanically what they've done is they have kind of two hinge joints, and they've placed one on top of the other. So the flexure is too high. Mechanically, I don't see a reason why they couldn't. The way it's set up, they could easily have them lined up, but they may be doing it for other reasons, and that is just leverage that they need to get, that they needed that offset in there. 1X is the only one that I've seen that actually has that down where it's supposed to be, which is why Neo's fingers look longer than everyone else's. It's like, it's actually the correct proportions. When you put a glove on it, it's going to look exactly like a human hand. But I agree, everyone else's fingers are flexing way too high, and it'd be nice to see them bring that down.
Also, maybe a dumb question, but when it comes to, so I think Tesla is designing all of its actuators in-house. Is that correct?
Designing, yes, but right now the components are being manufactured outside.
Correct. Yeah. So how much of a design challenge is it, and is it an inversely proportional relationship between kind of miniaturization and reliability and strength, or from an engineering point of view, Scott, when you design
all of
these
the above.
actuators and motors?
It's all of the above. I mean, you want to make these things as small and compact as possible to get them in there, but the smaller you make them, the less powerful they are, and then it almost defeats the purpose. Which is why, do we put them in the palm where they're going to be really tiny and ineffective, or do you put them in the forearm where we can make them a little bit bigger and then maybe get the strength that we want? So there's that trade-off. And then the other thing is, like, in the end, it doesn't matter how small and how cheap and all that stuff it is. If it's not reliable, it's of no value. So you've got to make sure that it certainly is reliable. And there's that tension, constantly trying to optimize it to cram them in. And no one's going to be satisfied, because right now,
how do you begin to strike the right balance between finesse and longevity and reliability?
See, this is a tricky thing. We're going to see dexterous hands that are very good, but just won't be reliable. And we'll see reliable hands that just are not dexterous at first. And this is why you have to make the decision, and kind of what, like I say, that's why UBTECH was so mid. They decided we want to have hands that are just for this particular job and will be reliable enough to do what we want. But we admit right out the gate, we're not going to be able to thread a needle. And they'll probably show a reaction to this where they do show it threading a needle. But, just kind of taking that for example, the real thing comes down to reliability and durability of your hands. And then the other thing is, like, well, also, how strong does the grip strength need to be?
Yeah.
We don't use our full clench every day. Usually it's very small. And if that's all you need, but every now and then we have to carry something very heavy, lift up that heavy carry-on bag.
Of course, our grip strength also varies, as in depending on how much you train your.
All that. Yeah. So it's there, but I want my bot to be so much. I want it to be delicate, yet at the same time, I want it to take me to the airport and pick up the luggage and all these heavy things and get them around. And every time you do that, you are degrading the lifetime of your bot, and especially if you're using tendons, because if you go outside the normal use of where they are, so the closer you get to the maximum peak strength of it, it's like this logarithmic thing that goes down. So if you stay well shy of that, you can get orders of magnitude more wear and tear out of your tendons. But if you're always using them at the limit, 100,000 cycles, and that's about it. You're not going to see a million cycles on those things. And you would like to see several million. So you either have to over-design the tendons to make sure they're nowhere near the maximum loading. Or I suppose, just make sure people don't abuse it.
Yeah, true. But I suppose that's also, when at the shareholder meet, I think Elon said that there would be subsequent versions of Optimus, almost one every year. I would imagine that they would actually learn a lot with the first version once it's out and actually doing work.
Yeah, and
I don't understand why.
That's why I wish they would not try to have such a perfect bot.
Yeah.
But
don't go for the surgeon in April. Just have it. Just have the hand that they had on Gen 1 would probably work for a lot of things. You can screw popcorn, you can open doors. Go for that. But Elon sets this goal. He wants everyone to have the best surgeon in the world in their house. And that would be very nice. But I don't see that happening in a year. And in that year, they will lose a lot of time. Yeah, and the hand, I expect, is quite easy to just swap out. But maybe I'm misunderstanding how hard it is to train it. So even if they send 1 million out with crappy hands, the data that they're collecting, they can't use for their dexterous surgeon hand that will come in 3 years. So maybe that data is not worth it. It's better to the others will still not be able to produce 1 million bots a year, which we will. So we have 6 months extra to design a better hand and then start cracking them out. We will still beat them in manufacturing numbers. Perhaps that's
I suppose that's a parallel you can draw with the number of cars in the Robotics, on FSD, right? The number of miles that you drive, the greater number of miles, the more edge cases, the more training data that you have. And that would transfer, that philosophy would that principle transfer also into bots, wouldn't it, Scott?
Yes, yeah. So hopefully there is that ability to transfer and move over. I'm I guess so. I guess I'm more bullish that you could use lower degree of freedom hands at first to collect a lot of data that could be of value. And then you're able to build on that training set. So, yeah, we'll see. Hopefully they start pumping them out in the springtime and getting them out in factories in other places where you start getting a good data set. But right now, I don't know what data they're collecting since Gen 3 is still on the board. Yeah. So that's like 18 months of no data.
Yeah. All right. So I know we're running out of time, and I want to quickly get to Mind-On, which is another and a bit of a hot take. But is there anything else that you would like to cover, Scott? In your slides?
No, that's it. That's it.
All right. So let me just quickly pull this up. And this is Mind-On. They released another Chinese bot company. They released. Is this a Unitree bot that they've?
Yeah, it's a Unitree bot with what looks like probably Robotics parallel grippers. So two finger grippers. And this is interesting. I almost wonder if that's mocap, because you notice how it's kind of wiggling when it's standing up there. That's exactly what a person would do when they get up there. You're not so sure of the balance, but when you're not on that platform, you're more stable. So to me, that's rather interesting, because I think normally the bot seems to be pretty stable. It looks like they took someone's grandmother and did motion capture on the movement. Now,
no scale's going to shock the box on the kid.
Yeah, there's a lot of people that are very impressed with this. I haven't been able to do like a full analysis or breakdown or talk to enough people, but you know, the few they are, they seem to be very impressed with what's going on. A few others are a bit skeptical about how it's being done. It may not be everything that you think it is. But it's still pretty impressive what they're able to do, and I don't know enough right now to know what are like the fine points here that really impress a lot of the observers that have been trying to do something exactly like this, and most of it comes down to they're impressed with the full body control
and the kind of the speed. It's very quick.
It's and they say that, I mean, because it's stressed, because it says at the bottom no speed up, no teleoperation, and
yes,
and it goes to show that you can do a lot with a pair of pliers or pincers. I mean, you don't need a dexterous hand to get into the kitchen and clean up or whatever.
So again, that's not the Unitree hand, because the Unitree has a lot of different options, and so they decided to fit their own hand, which they may have already been using in like other applications. And now, okay, that's impressive, because even I have a hard time throwing a frisbee well. So.
And this is some extra real. I don't know what's this. They kind of changed the design into some fake. It's not even Super 8. Super 8 was black and white, right? Or was it colored? I don't remember.
Yeah, I guess if you get the Kodachrome kind of colors there, probably towards the end, Super 8 had black and white, or had color. The thing is, at this point, they're not putting the sign up there that it's not teleoperated, so we don't know.
Yeah, that's maybe.
So they're not 100% sure there, because they make it very clear when it's not teleoperated. So that could have been like when they were doing a data collection or something like that.
Yeah, I think this is, let me just scroll back a bit to that, and then no speed up, and then this is where the little note at the bottom.
Yeah, the note goes away there. Yeah.
Yeah. And I just want to draw your attention to Brett, and this is what Brett says in response to this post. He says, looks like an open loop replay RL controller, so it's moving blind without perception, and it's running an open loop replay. Then at the end, when they grab the object showing perception,
no teleop,
they remove the no teleop language. So that is telling to me as well. Your thoughts?
Yeah, and he could be onto something, because again, I thought it was sort of funny when it was standing up there on the platform that it was wobbly.
Yeah.
And it's like, well, wait a minute. So they just actually capture a person going up and doing that. And now the replay is kind of showing the same shakiness that I would have when I'm standing up on a platform like that. Because I would think the bot itself, normally it's walking around on normal floor. So that's more of a psychological effect than anything else. So, you know, it's pretty stable there. And it's kind of cool that it decides to walk up there to do this. And is some of the wobbliness that's going on there because it's well, yeah, that's like, I'm nervous. I think I'm going to fall.
The table being unstable?
No,
I don't think it's because of the table, because that looks to be a rock solid table. And I don't think it's because it's pouring the water, and the water is kind of causing something, because it seemed like it was stable somewhere else. So I'm almost wondering, it's like, is that just an artifact from the training data where they may have done that many times, and then that's something that's in the motion capture data that you're now seeing replayed.
It looks almost like, I mean, the motion kind of looks like it's hanging on a, it's been like, if someone is hanging in a rope, that's kind of what it would look like.
Yeah.
But in that case, they have edited it out, and I don't think they do that now. I mean, the Chinese are really stepping it up.
Oh yeah, absolutely.
This was a Chinese company as well, right?
Yes,
Yeah,
it's a startup. Of course.
Startup, yeah.
It's always a
Like
startup.
in 2 weeks, there are 3 big
Yeah.
reveals or whatever.
Yeah.
So.
Yeah.
Yeah, and that dismount was really impressive because it kind of walks a bit like Jackie Chan.
Yeah.
As a very
And you
wide
see, you
stance
notice when
and
it stood up there, it also knew to take the dragging foot and get it out of the way.
Yeah.
Kind of gut around there, make sure it didn't hit.
And a big, it can really keep the knee high.
That's odd to me. It's like, wow, who trained it to bring it? Because my back is hurting watching it do that. You know, just kind of twisting around. It's like, oh, that. So some of the positions do not look natural. Yeah.
And this is quite, I mean, it's a quite soft mattress that it can keep the balance on just the knees in the beginning.
but it's not, I mean, whatever it's doing, it's not doing a very good job because there's not a
No.
And
It's definitely
they're the same. It's not scooping it into the tub. It's scooping it away
it brings
from
the
the
tub
tub.
up, but it goes away. I'm looking at that. It's like, wait a minute, it should be going in the tub. Yeah, exactly. So there's still a ways to go there in the improvement.
impressive nonetheless.
Yeah.
That's
And that's so it's getting a lot of traction. We'll probably find out more as time goes on. Again, I need to talk to some people who are really deep into this to see what it is about it that really impresses them.
Yeah.
Well, mind on. We'll be keeping our eye on you.
Yep.
We'll leave it at that. Thank you so much, gentlemen. Scott
You're welcome.
and Gustav. Always a pleasure. So much to learn from you guys.
Sure
Thank
is.
you. Till next time.
Same here. You're welcome.